All right, let's get right into it. We hear all the time about AI writing essays, making incredible art, even writing code. But what happens when we take it out of the creative sandbox and put it on the front line of critical engineering? Where one tiny mistake could have absolutely massive consequences. And that's really the big question we're digging into here. I mean, it's one thing if an AI messes up a rhyme in a poem, right? But it is a whole different ballgame if it miscalculates the stress on an airplane wing. The stakes, they couldn't be higher. So to really get this, we have to talk about a field called Reliability Systems Engineering, or RSE for short. Think of it this way. Pretty much anyone can design a car that goes 200 miles an hour. RSE is the magic that makes sure that car doesn't completely fall apart at 200 miles an hour. It is, quite literally, the science of preventing failure. Okay, so now that we're on the same page about what this super critical field of engineering is, let's see what happens when you throw a large language model into the mix. How is AI actually being put to its toughest test yet? You see, the whole point of RSE isn't just to reduce the chance of failure, it's to design systems for zero failure when it counts. We are talking about preventing actual catastrophes. And for a technology like an LLM, which, let's face it, works on probabilities and best guesses, this is just a monumental challenge. So how do engineers even begin to wrap their heads around a challenge this big? Well, they don't just wing it. They follow a super rigorous, structured plan for building reliable systems. It's called the V model. And this is it, the V model. Now, I know it looks a little complex, but it's basically the master plan for all of RSE. Think of it like a journey. You start at the top left with what you want to build. You go down through all the design steps, you hit manufacturing at the bottom, and then you come back up the other side, testing and verifying every single step. The beauty of it is that every step going down has a matching verification step coming up. Nothing gets missed. To make it even simpler, we can just boil that whole V model down to 5 key phases. It all starts with requirements. What does this thing actually need to do? Then you design it. After that, it gets manufactured. And then, this is crucial, it goes through verification to make sure it was built right. And finally, you have ongoing maintenance to keep it safe for its entire life. And this is where we start to see the potential for a total revolution. The old way of doing RSE involves so much manual work, with knowledge locked away in different teams. But bring in an LLM, suddenly you could have automated insights, a unified understanding of the entire system, and get this. You could move from fixing things after they break to predicting when they might fail and stopping it from ever happening. But, and this is so important, you can't just grab any old chatbot and ask it to design a jet engine. No way. The research is crystal clear. These LLMs have to be specially trained or fine-tuned on mountains of high-quality, specific engineering data to turn them into expert tools. And when you do that fine-tuning, the results are, well, they're kind of mind-blowing. In one study, a fine-tuned LLM hit 97% accuracy, finding critical security flaws in smart contracts. That's a field where one tiny bug can literally cost millions of dollars. Or check this one out. An LLM was able to figure out the health of really complex machinery. Think giant turbines with over 93% accuracy, even when it only had scraps of information to work with. That is a massive deal. And this last one really shows the real-world impact. By plugging a fine-tuned LLM into a system for industrial cranes, engineers saw almost a 31% jump in how accurately they could diagnose problems before they turned into disasters. The potential here is just enormous. But, as incredible as all that sounds, we've got to pull back from the hype for a second. It is definitely time for a necessary and very serious reality check. Because in the world of art or poetry, close enough is usually fine. But in reliability engineering, close enough can mean catastrophic failure. 99% accuracy is not good enough if that 1% leads to a bridge collapsing. So, this chart here is a standard tool in RSE called a failure modes and effects analysis. And when researchers gave an LLM a really simple task using this, just analyzing what might go wrong with a simple bearing, the results were, well, let's just say they were pretty concerning. The AI made some really basic mistakes. It hallucinated. It just made stuff up. It got core concepts totally mixed up. It made simple math errors. It just didn't have a systematic analytical approach. And maybe the biggest problem of all, its reasoning was a complete black box, making it totally impossible to trust how it got its answer. So the researchers basically boiled it all down to these 3 massive roadblocks. First, There just isn't enough good data on failures to train these AIs properly. Second, engineering itself is just incredibly complex. And third, that lack of explainability. That's not just a problem, it's a critical show-stopping deal breaker. You simply cannot bet people's lives on an answer when you don't know how the AI got it. So is that it? Is this just a dead end? Absolutely not. The research actually lays out a really clear path for how we can move forward and overcome these challenges. The answer isn't to give up, it's to get way smarter. First, we need to build foundational AI models trained specifically on high-quality industrial data. Second, we have to make them more flexible by combining them with other models that are good at handling uncertainty. And finally, and this is non-negotiable, we need a rock-solid system for testing and validating every single thing the AI spits out. And all of this leads to what is maybe the most powerful and important idea in the whole paper. The future isn't a choice between a human or a machine. It's about creating something totally new. This quote from the research really says it all. The real goal here is to build a composite system where you get the best of everything: the strengths of human experts, the power of analytical tools, and the speed of AI, all working together as one. So, if you take one thing away from this, let it be this. The AI is not coming for the engineer's job. It's coming to be the single most powerful tool that engineer has ever had. It's all about making human experts even better, not replacing them. It's about building a team. And that leaves us with one final thought to chew on. In those moments where everything is on the line, when safety and reliability are all that matter, the answer isn't to trust just the human or just the AI. The future of engineering, and maybe a lot more, is going to depend on our ability to trust the team.